Okay guys, welcome to this Key Stage 4 question bank on Pythagoras' theorem from the White Rose Maths website. So this is a White Rose Maths made PowerPoint made by them. And we're looking at Pythagoras' theorem. So again, quite a big topic on the GCSE 9-1 maths curriculum, involving the formula a squared plus b squared equals c squared for right angled triangles only. So remember that the key part of today's video is it has to be a right angled triangle that we are obviously working with in today's video. So we will just obviously crack on, guys. It is quite a long video, guys, so please do grab a drink, grab a tea, coffee, make some notes, dip in and out of it as and when you need to. It will come to be over an hour, possibly even an hour and a half, but let's just get on straight onto the video. Let's go. This is the first set of questions. Complete the statement using less than, greater than, or equal to. So 5 squared means 5 times 5, which is equals to 25. 5 fives are 25. The square root of 100 is equal to 10 because 10 times 10 is 100, or 10 squared is 100. Therefore, this answer is bigger, so the crocodile's mouth is eating the bigger number. This is greater than this. This next one, the square root of 9 is 3 because 3 times 3 is going to be 9. And 3 squared means 3 times 3, which is 9. Therefore 3 squared is greater than, i.e. bigger than, the square root of 9. 4 squared means 4 times 4, which is 16. The square root of 64 is going to be 8. 4 squared is bigger than the square root of 64, because 8 times 8 is 64. So again, that was a little starter, guys. There we go. So second question. Here is a right angled triangle. Work out the length of the side labelled C. So I'll label this as A and this is B. Now the formula is as follows here. So it's A squared plus B squared equals C squared. Now at the time of recording this video in 2024, you will be given this on this year's formula sheet. However, if you're watching this video next calendar year or the future calendar years, this may not be given to you, so it might be worth learning this in the future years. But at the time of this video being uploaded and recorded, the formula sheets are being given for this year's GCSE exam. So for the summer exams 2024 and the November exams 2024. But next year's cohort will not be given, unfortunately, this formula. So maybe worth actually learning this formula. It's quite an easy formula to learn. So I'm going to have 9.8 squared plus 6.3 squared is equal to C squared. Therefore C is going to equal to the square root of 9.8 squared plus 6.3 squared. I'm going to bring that into my calculator. And when I do that, I get C is equal to 11.7 to 1 decimal place. Centimeters to 1 decimal place. So that's my answer for this question here. This next one, similar idea. Here is a right angled triangle. Diagram is not actually drawn. Work out the length of side labelled F. So it'll be 20 squared plus 15 squared is equal to F squared. Again, they will obviously use any letter in the exam. So don't be put off by what letter they use. You're going to have 400 plus 225 is equal to F squared. So F squared is equal to 625. And if I square root both sides to get F, so F equals the square root of 625, which gives you the answer of 25. So 25 meters. So a few points here to actually note, guys. Remember that the hypotenuse, so this is what I call the long side here, so it's what I call the hypotenuse, Okay, so that is the mathematical term of the longest side of a right angle triangle, and it's always directly opposite the right angle. Okay, for that one. Okay, so that is a little trick to know that if you're going to be adding or subtracting, guys, in your formula equation. Okay, remember it's a squared plus b squared is equal to c squared, guys. Okay, c squared. Okay, made a mess there. Okay, for that. Okay, hopefully that makes sense. There we go. Okay, this next one, similar idea. Work out the length of xy. Here is a right angled triangle. Okay, right angled. Work out length of xy. So we'll label that as just x. So we'll have x squared is equal to 9 squared plus 12 squared. Okay. X squared is going to equal to 81 plus 144. Okay. So x squared is going to equal to 225. X is equal to the square root of 225, which gives you the answer of 15. So length of xy is 15 centimeters. Okay, so xy, okay, length is equal to 15 centimeters. Okay. And a quick note, guys, here. So a little off-topic note here. So at this stage here, I technically need a plus and minus root this. However, I can disregard the minus root 225 or the minus root of a number in this context because I'm looking at length. Okay, so I can disregard the negative sign. Normally, if you have x squared equals a number, okay, x always has to equal plus or minus the square root of that number. So x equals plus or minus root 25, which is plus or minus 5. Okay, but in this context, I can disregard the negative sign, okay, because I'm looking at length here. Okay, so bear that in mind, guys. Okay, yeah, so you might get like a negative length, and a part B might say to you, why can it not be minus 15? Because I cannot have a negative length. Okay, so again, yeah, so it's these like little common mistakes, as in common misconceptions to deal with. Okay, there we go. This next one, okay, so it's a bit more tricky here. So we've got 9.1 squared plus 7.2 squared. Okay, square rooted is equal to y. Okay, so using that formula, a squared plus b squared equals c squared. Remember that c is always the square root of a squared plus b squared. Okay, where c in this case is the hypotenuse. Okay, so always remember that as well, guys. Okay, so if you work this out, guys, we will get that y is equal to 11.6 millimeters to 1 decimal place. Okay. Okay, this next one is a bit more trickier now. This time we are given the hypotenuse and we've got to work out the shorter side length. So this time I can set up an equation. So I'm going to have b squared plus 1.4 squared. That has to equal to 1.9 squared. Okay, think of that as your b, that is your a, and that is your c. Okay, I'm now going to rearrange it, so I'm going to have b squared is equal to 1.9 squared, subtract 1.4 squared, and then the final step is b is equal to the square root, okay, of 1.9 squared, subtract 1.4 squared. I can then bing this into my calculator, and if I do that, I get an answer, okay, of 1.28, okay, meters to 2 decimal places, okay. So 1.28 or 1.3 meters Okay, either answer would suffice. Okay, and a little way that you know that you are correct here or on the right lines, these two numbers have to be smaller than 1.9. Okay, so if B came out as 2.0, then I've definitely made a mistake, because the two shorter lengths have to always be smaller than the longest length, which is the hypotenuse here in this context. Okay, so my answer has to be explicitly smaller than 1.9. Okay, in this context. Okay, so I've definitely got it correct, actually, yep, or on the right lines. Okay, this next one here is right angled triangle. Okay, so I've got the hypotenuse there, so label that as H or C, label that as C, label that as G, and label that as A, let's say, or B, you could say. So I have G squared plus 12 squared is equal to 15 squared. Okay, rearrange this, so subtract 12 squared on both sides and then square root it. So sorry that I'm doing it in like one actually step actually, or more than actually one step actually, but hopefully you're happy with that. So it's 15 actually minus 12 actually square rooted. Okay, so G is equal to 225, subtract 144, and if I'm not mistaken, minus 144, so that's going to be 1, knock off the 1 there, 12 take 8 is going to be 8, 1 take 1 is going to be 0, so G is going to equal to the square root of 81, which is equal to 9, okay, so G is equal to 9 millimeters. Okay, there we go. Or B in this case, yeah, it's done. Okay, here is a right angled triangle. Okay, work out the missing length, P. Okay, so be careful here because I've got different units here. So let's change this into centimeters by times it by 100. So it's going to be 400 centimeters. Okay, so now I'm going to have 90 squared plus 400 squared is equal to P squared. Okay, or that and then square rooted to work out what P is, which is the hypotenuse. If I simplify this, I'm going to get the square root of 8,100 plus 1, 6, and then 4 zeros. So 160,000, I believe. Okay. So if I do this, okay, so I'm going to get the square root of, so let's just obviously add this up quickly. Okay, being very careful with my place value, 0, 0, 0, 1, 4, and then I'm going to put a 1 there. So it's the square root of 241,000, which I don't know what that is just here on top of my head. I'll bring that into my calculator, okay, and I get the answer of 410. Okay, so P is equal to 410 centimeters, or 4.1 meters. Okay, either answer would suffice. Okay, there we go. Okay, PQRS is a rectangle. Okay, Danny has made a mistake when calculating the length PS. So PS is going to be this length here. Explain Danny's mistake. Okay, so they should have actually added it, okay, instead of subtracting it, okay? So it should be a plus there, not a subtraction, okay? Because PS is actually the hypotenuse in this context. So it should be 12 squared plus 5 squared. So it should be, PS should be 13, not 10.91, okay? Because if you think of it as a triangle, okay, if we're not sure, the right angle goes there. We've got 12 and 5. Okay, this is what we call PS. Okay, so it'd be PS squared is equal to 5 squared plus 12 squared. If we simplify this here and rearrange it, we'll get PS is equal to the square root of 25 plus 144, so that'd be the square root of 169, which is equal to 13 centimeters. Okay, so PS is equal to 13 centimeters, guys. Okay, there we go. There should be an add, not a takeaway. Okay, the diagram shows a right-angled triangle on a centimeter square grid. Calculate the perimeter of the rectangle of the triangle. Sorry. So 1, 2, 3, 4, 5, 6. So it's 6 by 1, 2, 3, 4, 5, 6. So it's 6 by 6. So this will be the square root of 72. Okay, the perimeter, okay, will be 6 plus root 72. So P is equal to 12 plus root 72. Okay, that'll be in what we call its exact form. Actually, yeah, and if I bring that in my calculator, okay, I could also write it as P is equal to 12 plus 6 root 2. If I simplify that third, okay, right, root 72, yeah, is root 36 times root 2. Okay, so that is my exact answer. Okay, and we'll leave it as that actually. So we'll leave it as that actually. But you can just put in your calculator and you'll get an answer. Okay, so okay, because it doesn't actually say around it here. Okay, so that will come out to be approximately 20.4 centimeters, guys. Okay, because root 2 is approximately 1.41 something. Okay, 6 times that will be like 6 point, or like, yeah, or like 7 point something. Plus obviously it'll be like 19 actually point something, or yeah, 20 point something. Okay, there we go. Okay, so I'm gonna have to split this, okay, into a triangle. So I'm gonna have 2 there. 1, 2, 3, 4, 5. Okay, so 2 with 5. So it'd be 2 squared plus 5 squared square rooted. So that's going to be the square root of 29 when you simplify that. Okay. This distance here will be 1, 2, 3, 4, 5. That'll be 5. That'll be 6. And that will be 7 if I'm not mistaken. So that should be 5 there. 1, 2, 4, 5. Just double checking. So the perimeter will be 7 plus 5 is going to be 12, plus 6 is going to be 18. So we've got 18 plus root 29, okay, and that's in its exact form, okay. If you bring it in your calculator, you will get the answer of 22.30 centimeters to 2 decimal places, okay, for that. 39, sorry, 39, I apologise, sorry. 39. Okay, but I was close enough, guys, yeah, I was close enough. Okay. Okay, show that the triangle is not right angled. Okay, so 6 squared plus 9 squared, okay, in this case, okay, needs to equal 11 squared. Now, if this is not true, then it's not right angled, okay? So that'll be 36 plus 81 has to equal to 121. Well, first of all, 6 plus 1 is going to be 7. Okay, so I get 7 there. 3 plus 8 is going to be 11. So I get 117 here. Does that equal 121? Well, it doesn't. Therefore, this triangle is not right angled, okay? So you use Pythagoras to prove that it's not right angled, okay? There we go, okay? There we go, bang. Okay, show that the triangle does have a right angle. So 5 squared plus 12 squared, does that equal 13 squared? Let's obviously find out. Okay, that'll be 25 plus 144. 13 squared here equals 169. Okay, 4 plus 5 is going to be 9. 4 plus 2 is 6, and then I've got the 1 there. So that is true, yes. 169 does equal 169. Therefore, this triangle is right angled, okay? By Pythagoras' theorem, okay? So that is correct. Okay, Whitney says that a triangle with side lengths 8 centimeters, 10 centimeters, and 15 centimeters is a right angled triangle. Determine if Whitney is correct. Well, does 8 squared plus 10 squared equal 15 squared? Well, thinking about it, actually, I don't think it does actually, because we'll work it out. So that'll be 64 there, plus 100. Okay, equal 225. So does 164 equal 225? It doesn't. Okay, therefore Whitney is actually incorrect. Okay, so it doesn't equal actually, yeah. So Whitney, what a name that is not correct. Should be an E there. Okay, there we go. Okay. Determine if the largest angle of the triangle with side lengths 9, 12, and 14 is an acute, obtuse, or right angle. Okay, so using Pythagoras here, so does 9 squared plus 12 squared, does that equal 14 squared? Well, 9 squared equals 81, 12 squared equals 144, 14 squared actually equals 196. So let's have a look here, guys. So 1 plus 4 is 5. 8 plus 4 is going to be 12. So 2 carry the 1. 1 plus 1 is going to be 2. Okay. So it is not a right angled triangle. Okay. So that tells me, okay, that the largest angle of a triangle of this side, well, that will have to be like a scalene triangle, okay? So it would have to be acute, okay? That'll be the largest angle, okay? Yeah. So because the hypotenuse is smaller than the sum of the side lengths squared, okay, that tells me that the largest angle must be acute, guys. Okay, so this one here is quite similar. Okay, so the largest angle, okay, so biggest angle, so 9, 12, and 15. Well, this one is around, if I remember correctly, yeah, so that'll be 9. I can't even write, guys, tonight, I apologise. So 9 squared plus 12 squared, does that equal 15 squared? I think it does, yeah, I think it does, guys. So that's going to be 81 plus 144. Does that equal 225? Well, yes, it does. Okay. 1 plus 4 is 5. 8 plus 4 is going to be 12. So 2 carry the 1. Okay, 1 plus 1 is 2. So that is correct, yes. So the size of the largest angle in this case will actually be a right angle. Okay, because it's a right angle triangle. Okay. These two would obviously be acute. The largest angle would obviously be a right angle. Okay, so it'd be a right angle, because this forms a right angle triangle using Pythagoras' theorem. Okay, sorry about my handwriting, guys. There we go. Okay, so this one's getting a bit more trickier now. Okay, remember, yeah, that it's not the same units here. Okay, so straight away, change that into 17,000 to make it a bit easier. Meters Okay, so an airplane is about to land at the airport. The airplane is 6,200 meters above ground level. The airport is 17 kilometers away. Work out the distance between the airplane and the airport. So again, it will be 6,200 squared plus 17,000 squared. Okay, that will have to be square rooted. Okay, if I bring this to my calculator, I get an answer of 18,100, okay, meters. Okay, so 18,100 meters or 18.1 kilometers. Okay, so either answer would suffice, or 18.1 kilometers, guys. Okay, there we go. Okay. Okay, draw a right angled triangle with base of 4 and a perimeter of 12 on a centimeter grid. Okay, so it has to have a perimeter of 4. Sorry, a perimeter of 12, sorry. So there's 4 there. Well, straight away, the remaining perimeter has to add to make 8. Okay, so to make 8, okay, I can have the 3, so 4 by 3, okay. That'll be 5 there, because 3 squared plus 4 squared will be 16 plus 9, which is 25. Squared, so root 25, guys, gives me 5. So that's where that 5 has come from. And if you add it together, the perimeter gives you 12. Okay, 5 plus 3 is 8, 8 plus 4 is 12. There we go. Okay, make sure you obviously label it. Okay, the diagram shows a line segment drawn on a centimeter grid. Okay, work out the length of the line segment. Okay, so it goes across 3 and up 4. Okay, so it's a 3, 4, 5 triangle. But again, we'll obviously show it. So 3 squared plus 4 squared is equal to, we'll call that y for this case, is equal to y squared. So we've got 9 plus 16 is equal to y squared. So therefore y is equal to the square root of 25, which is equal to 5. Length that is equal to 5. Okay. Work out the distance between points A and B. Okay, so it goes across 1, 2, 3, and it goes up 1, 2, 3, 4. Again, it's a 3, 4, 5 triangle. So distance of AB will be 3 squared plus 4 squared square rooted. If you simplify that, you'll get the square root of 25, which is 5. Okay, 3 squared is 9, 4 squared is going to be 16. So AB is equal to 5, guys. Okay, there we go, 3, 4, 5. Okay, so calculate the perimeter of the triangle formed by joining points A, B, and C. Okay, so we're going to have, so it's 0 to 7, so it goes up 7, goes across 2, so it'd be 7 squared plus 2 squared square rooted, so that'd be the square root of 49 plus 4, which would be the square root of 53. Okay, leaving it in its exact form. Okay, so the perimeter will be 2 plus 7 plus root 53. So in exact form, the answer would be 9 plus root 53. Okay, and if you bring that into your calculator, you will get a numerical answer, guys. Okay, so you'll get an answer of 16.3, okay, to 1 decimal place, guys. So 16.3 centimeters, guys. Okay. Just join it up there so you can see we've got a triangle. Sorry, it's not drawn very well there. Try and get a bit more straight line. Oh, a bit more tricky that is. Okay, you got that one there. Okay, there we go. Okay, there we go. Okay, so triangle XYZ has a perimeter of 15 centimeters. XY is 4, YZ is 5. Determine whether triangle XYZ is a right angle triangle. Well, does 4 squared plus 5 squared, so 4 plus 5 is equal to 9, okay, 15 take away 9 is 6, okay, so does 4 squared plus 5 squared actually, does that equal to 6 squared? Well, it doesn't, because that's going to be 16 plus 25 is 36. We get 41 equals 36, which is not true. Okay, so not true, or not true, okay, or not equal to, okay, therefore XYZ is not a right angle triangle. Okay, right angle triangle. Okay, I'll label it as RAT, the same as of writing it. Okay, right angle triangle. There we go. Okay, work out the side of W. Okay, right, so this will be W here. Okay, this will be 61. That's 40. So therefore, this has to be 21. No, sorry. Yeah, that's right. Yeah, that's right. Sorry, yeah. Okay, so it's a right angle triangle. So it'll be 35 squared, take away 21 squared, square rooted, has to equal to W. If we bring that into a calculator, we'll get that W is equal to 28 centimeters long. Okay, there we go. Okay, hopefully that makes sense. Okay guys, next question. The diagram shows a trapezium. Part A, work out the height, h to the trapezium. So working out the height. Okay, remember that we have to convert it into the same units. Okay, that will be 0.3 meters. Okay, because 0.3 plus 1.4 is 1.7. Okay, that plus that is 1.7. Okay, so in centimeters, that will be times it by 100, that will be 30 centimeters. So the height will be 50 squared, subtract 30 squared, square rooted. Okay, so we'll take time actually working this out. We get the square root of 2,500, take away 900, which is the square root of 1,600 or 1,600, which equals to 40, guys, equals to 40. Okay, 40 centimeters or 0.4 meters. Okay, there we go. Oh, sorry. So that was actually part A. Sorry, I didn't actually work out part B. Sorry. So part B, the area of the trapezium. If you're not sure, it'll be the sum of the parallel sides. So 1.7 plus 1.4. Okay, divided by 2, multiplied by the perpendicular height, so times by 0.4. Okay, if you bring this to calculator, we get the answer of 0.62. Okay, and the units are meters squared. Okay, sorry about that, I do apologise. I was rushing there as usual. Okay, this next one, here is a right angle triangle, diagram not drawn accurately. Calculate the area of the triangle. Well, I've got to work out the base, I've got the height. Okay, so to work out the base, it will be b squared plus 8 squared is equal to 17. If I rearrange this by subtracting 8 squared and then square rooting both sides, we have b is equal to the square root of 17 squared minus 8 squared. That will be the square root of 289 minus 64. Okay, so that'll be the square root of 225, which will equal to 15, guys. So the base is equal to 15 meters. Okay, I can now use the formula base times height divided by 2. Okay, if it's a right angle triangle, remember. So 15 times 8 divided by 2. Make this a bit easier for me. Divide top and bottom by 2. That goes to 1. That goes to 4. 15 times 4 is going to be 60. 60 over 1 is going to be 60, guys. So the area is 60 meters squared, guys. Okay, that's the area of the triangle. Okay, hopefully that makes sense. Okay, there we go, guys. This next one, here is a right angle triangle. Calculate the area of the triangle. Again, I need the, well, I've got the base here. I need the perpendicular height, or the base, you could say. Okay, so to work out the height, you could say, so 11 squared, take away 5 squared, square rooted, is equal to h. So h is equal to the square root of 121, subtract 25. Okay, that will be the square root of 96, if I'm not mistaken. Okay, because 121 subtract 21 goes to 100, and then minus 4 is going to be 96. Okay, so leave that as root 96 for the time being. Okay, so the area, okay, will be base times height divided by 2, or a half base times height. Okay, either way. Okay, it'll be 5 times root 96 over 2. So let's just simplify this part first to make it a bit easier. So it's 5 times the square root of 16 times the square root of 6 all over 2. That goes to 4 when I simplify that. So that goes to 4. So the square root of 16 is going to be 4. Divide top and bottom by 2. I get 1. I get 2 there. 5 times 2 is 10. So my final answer is 10 root 6, okay, centimeter squared in exact form. Or if we bring it into our calculator, we will get the answer, okay, so root 6, okay, hang on a second, sorry. So root 6 times by 10, I will get the answer approximately of 24.5 centimeters squared to 1 decimal place, guys. Okay, hopefully that makes sense. Okay, for that one. Okay, there we go. Okay, this next one. So here is a trapezium. Work out the area of the trapezium. Okay, so then I've got to work out the length here, or the height, you could say. That's 20, all of that. That's going to be 12. So that there has to be 8, because 8 plus 12 is 10. So I'm going to have 18 squared minus 8 squared, square rooted. So 18 squared is going to be 324. Subtract 64. So that'd be 260. Okay. So the square root of 260. Okay, so if I press the square root button, I get 16.12. Okay. But we'll leave it as that actually for the time being actually, and we'll write it at the end actually here. So area will be the sum of the parallel sides. So 20 plus 12 divided by 2 multiplied by the square root of 260. Okay, so that'd be 32 halves, so that'd be 16 root 260. Okay, I'm now going to multiply this by 16, so I get the answer of approximately 257, okay, 0.99 centimeters squared to 2 decimal places, guys. Okay, and that's my answer for that question. Okay, yep, or 258. Okay, either one. Okay, the diagram shows a quadrilateral made from two right-angled triangles. Calculate the length of the side labeled F. Okay, so step one is to work out the hypotenuse of this triangle here. So the one that I've done in red. So work out this length here. I'll call that H. Okay, so H is going to equal to the square root of 9.2 squared plus 12 squared, sorry. Okay, so if I work this out, okay, we get that H is equal to the square root of 96.64. Okay, is that right, guys? So let's double check, sorry. So 9.2 squared, yep, 84.64, and then plus 144. Oh no, sorry guys, I've made a mistake here. It should be 228.64, sorry. So 228.64, okay? So that is going to be that length there, okay? Now, to work out F will equal to this number squared, so that would be 228.64, okay, plus 10.5 squared, so that'd be 110.25. 110.25, and then we'll have to obviously square root that at the end. Okay, so plus 228.64 equals square root answer, and we get that the side length F is approximately 18.41 millimeters to 2 decimal places. Okay, there we go. Okay, the diagram shows an isosceles triangle, guys. Okay, work out the area of the triangle. Okay, so the area will be the length times the base. Okay, so I can split it into two right angle triangles. Okay, that will have a length of 9. To work out the height, it will be 11 squared minus 9 squared square rooted. So that'd be the square root of 121 minus 81, which I believe will give you the answer of 40. So root 40. Is that right? Let's just double check. Yes, we are right. So root 40. Or I can write that as root 4 times root 10. So that'll be 2 root 2 if you simplify that third. Okay. So 2 root 2. Sorry, 2 root 10, sorry. Okay, so 2 root 10. So the area will be base times height divided by 2. So 9 times 2 root 10 divided by 2. Well, the 2's will just cancel. So I'm left with 9 root 10 centimeters squared in its exact form. Okay. The square root of 10 is approximately 3.16, times that by 9. Okay, and I get the answer of 28.46 centimeters squared to 2 decimal places, guys. Okay. Oh, have I made a mistake there? No, I haven't, I don't think. Oh, sorry, yes, sorry, it's a half times 18, not a half times 9. Sorry, I apologize. Sorry. So you would obviously double my answer, and it would give you that actually. Yes. Sorry about that, guys. Okay, work out this length of the side label D. Okay, so we will use Pythagoras here to work out this length here. So we'll call this H. So H is equal to the square root of 13 squared subtract 5 squared. If we simplify that, we're going to get 169 take away 25, which is going to be 144. So square root of 144 is going to equal to 12, guys, okay? So that one's going to equal to 12. So 12 centimeters. And then to work out D, it will be 12 squared plus 9 squared square rooted will give you what D is. And that, guys, will be your answer. Okay, so whatever that is. So 12, so that'll be 144 plus 81. Okay, so that'll be the square root of 225. So that'll be 15. So D is equal to 15 centimeters. Bang, there we go. Okay, an isosceles triangle has a base of 10 centimeters and a perpendicular height of 13 centimeters. Work out the perimeter of the rectangle. Okay, so if the height is 13, okay, I'll label this as 5. Okay, 13 square. Oh no, sorry, that is the height there. Sorry, I apologize. Okay, 13 squared plus 5 squared square rooted will give me the slanted height. I'll call that x, which is equal to x. Okay, that'll be 169 plus 25, which is 194. Okay, which is nearly 14, guys. Okay, because 196 rooted is 14. Yep, so it's 13.9. Okay, so 13.928, we'll say. Okay, so the perimeter will be that plus 13.928 plus 10 will give me my final answer. Okay, so times that by 2 and then add 10 and then we'll round my answer. Okay, that's approximately 37.86 centimeters. Okay, there we go. Okay. Okay, this next one is a bit more trickier now. The diagram shows a square contained inside a larger rectangle. Each vertex of the contained square is the midpoint of the side lengths of the largest square. So calculate the perimeter of the contained square. So that's 6 there. That's 6 there. That's 6 there. That'll be 3 there. That'll be 3 there. So that'll be the square root of 9 plus 9, which would be 18. Okay, so that'll be 4 lots of root 18. Again, if we simplify that, we'll have 4 lots of root 9 times root 2. So that'll be 4 lots of 3 root 2. So our final answer would be 12 root 2 centimeters in its exact form. Again, if you're beating the calculator, root 2 is approximately 1.41. So root 2 times 12 will be 16.97. Okay, so it's approximately 16.97 centimeters to 2dp. Okay, that was quite a nasty question. There we go. Okay, the square ABCD has an area of 2.25 meters squared. Calculate the length of diagonal AD. So first part is to obviously square root that number. Okay, so the square root of 2.25, that will give you 1.5. Okay, 1.5 plus 1.5. To work out length AD, it'll be 1.5 squared plus 1.5 squared square rooted. So it'll be the square root of 4.5, which is exactly, okay, so what I'll do is I'll write it as root 9 over 2. So that'd be 3 over root 2. If you rationalize that, so times top and bottom by root 2, we'll get 3 root 2 over 2. So that's my exact answer, okay, for the length AD in meters. Okay, so 1.5 times, so times that by 1.5, and we get the answer of approximately 3.18 meters to 2 decimal places, guys. Oh, what? Okay, I think there's a mistake there, guys, because 1.5 times 1.5 is 2.25. Okay, so 2.25 plus 2.25 is a square root of 4.5. Okay, so why did I put that as root 9 over 2? Sorry. Okay, so I think I made like a mistake there. That's fine. Okay. The diagram shows two right-angled triangles. Determine if these two triangles are congruent. Okay, so 6 squared plus 8 squared, that will give you 10 there when you work it out. Okay, because it gives you 100. Square root of 100 will be 10. And then 10 squared minus 8 squared is equal to 36. Square root of that, yep, so that is true. Yes, so the triangles are congruent, yes. Because it follows the rule side, side, side. Okay, so just a quick recap, guys. Yeah, for congruency, you've got side, 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 angle, side, angle, side, angle, side, and RHS, right angle, hypotenuse, and the side. There we go. So that is right. Okay, here is a square and a circle. The square has length of 4 centimeters. The circle has diameter of 6 centimeters. Show that the square will fit inside the circle. Okay, the area of the square is 4 by 4, so that will be 16 centimeters squared. 4 times 4. The area of the circle will be pi times 6 squared. Now, as long as this answer is bigger than or equal to 16, then I'm in the safe zone. Okay, so that will give me 36 pi, okay, centimeters squared. That is definitely bigger because pi is 3.14, is 36 times 3.14, okay, 141. Actually, that's clearly bigger than 16. Therefore, the square will fit inside this shape. Okay. Okay, that is another way of doing your answer. Okay, but my way also works. Okay, here is a right angle triangle. Work out the value of v. So we're going to have v is equal to the square root of root 11 squared plus root 5 squared. Okay, so if we square a surd, yeah, or a root, so root 11 squared is just 11. Okay, so we're going to have the square root of 11. Root 5 squared will be 5. 11 plus 5 will be 16. So the square root of 16 gives me the answer of 4. So V is equal to 4. Okay, 4 centimeters. There we go. Okay, this next question, which point is 10 units away from the origin? So 10 units. Okay, so the origin, let's say, is here, which is 0, 0. So it's saying which is 10 units away. So I'm guessing, so it means like you're like a distance of 10. So 10 horizontal, 10 vertical, 10 that way, or 10 that way. Okay, so this first one, let's say it's 5, 5. We'll put that there roughly. Okay, so it's 5 across and 5 up. That's 5 by 5. That's a triangle. That'll be the square root of 50. Okay, the square root of 50 is approximately 7 point something, so 7.07. Okay, so it can't be that one. Okay, what about this one? So 12 minus 2, somewhere down here. So that'll be the square root of 12 squared plus 4 squared, or minus 2 all squared. So that'll be the square root of 144 plus 4. That's definitely bigger than 10, because the square root of 100 is 10. So that's way bigger than 10. Okay, so therefore it's not that one either. Okay, that'll be 81 plus 1. That'll be the square root of 82. That's smaller than 10. So it can't be that one. So it has to be this one. Okay, we'll check it by doing 8 squared plus 6 squared, square rooted. If you simplify that, you will get the answer of the square root of 100, which is 10. Okay, there we go. Okay, or minus 6 squared, actually, yeah. Okay, so this next question. Here is a right angled triangle. Find the value of t. Give your answer in the form a root b, where a and b are integers. So I'm going to have 2 root 5 all squared plus 2 root 2 all squared. And this will all be square rooted to work out what t is. Okay, so I'm taking my time with this. So if I square this, 2 times 2 is 4. Root 5 times root 5 is 5. 4 times 5 is going to be 20, so I'm going to have 20 there. Plus, now 2 squared is going to be 4. Root 2 squared is going to be 2. 4 times 2 is going to be 8. So 20 plus 8 is going to be root 28. Now if I simplify this third, I can write it as root 4 times root 7, which simplifies to 2 root 7. So t, okay, t is equal to 2 root 7, where a is equal to 2 and b is equal to 7. There we go. Okay, looking at some 3D Pythagoras now. Okay, the diagram shows a cube with side lengths of 7 centimeters. Okay, so that's 7, and that's 7. Work out the length of the longest side of the cube. So that'll be from here to here. Okay. Now, if you look here, that is actually, that is just quite tricky. So if I work out the length EG, okay, so that'll be 7 squared plus 7 squared, so that'll be root 59, actually, yeah, plus root 59, so that'll be the square root of 98, okay, and then to work out what EC is, which is the longest length, okay, that'll be 98 plus 49 square rooted. If I work this out, I'm going to get 147 square rooted, okay, which if I bring it into my calculator, I will get the answer of 12.1, okay, centimeters to 1 decimal place, guys, okay? So this is looking at some 3D Pythagoras, okay? So looking at some visualization skills here, okay? There we go. Okay, so work out the length of AG. So that would be AE plus EG. Now, I've got to work out what EG is first, okay? AE, I know that's equal to 40 centimeters. To work out EG, that would be this one here, so that would be 0.6 here. I'll put that in meters here and then change it at the end, okay? So that'd be this squared plus this squared, okay, because that's my right angle here, you can see. Okay, so it'd be 0.6 squared plus 1.2 squared square rooted to work out what, so that would be EG. Okay, so that'd be the square root of 0.36 plus 1.44. So that'd be the square root of 1.8, if I'm not mistaken, or 1.80. A square root of 1.80. Okay, that will be 0.4 in meters. Okay, so AG will be the square root of 0.4 squared, so that'd be 0.16 plus 1.80. So that'd be the square root of 1.96, which if I work it out, I get 1.4 meters or 140 centimeters. Okay, either answer would suffice. There we go. Okay, so the diagram shows a cube with a volume of 8 meters cubed. Work out the length of CE. So CE. Okay, step 1 is to work out your side lengths. So the volume, so working backwards, if I do the cube root of 8, that will give me what the side length is, okay, because that's x there, that's x there, and that's x there. X times x times x equals x cubed, so x cubed is equal to 8, so to work backwards, I do the cube root of 8 equals x, so x is equal to 2 centimeters. Okay, again, I've not covered the module on volumes yet, but I'll cover that in like a future video, so watch out for that, okay, because by the time obviously this is actually posted, then I might be recording the volume video. But to work out the volume of a 3D shape is, or in this case a volume of a cube, is length times width times height, okay, so it's area of the cross section times the length or height, okay. So it's 2 there, it's 2 there, and it's 2 there. Okay, so to work out EC, I've got to work out what EG is first, and then I've got to use this other triangle. So that'll be 2 squared plus 2 squared, so that'll be the square root of 8. Okay, so EC will be the square root of root 8 squared plus 2 squared. So that'll be the square root of 8 plus 4, which is 12, so it's root 12. I can simplify that, okay, write it as root 4 times root 3, which is equal to 2 root 3. Okay, so yeah, so the answer would be 2 root 3 for CE, okay, and again, that's the exact answer, okay. So 2 root 3, which is approximately 3.46 meters on my calculator. Okay, meters and not centimeters, sorry. So meter, sorry. There we go. There we go. Bam, we got it. Okay, so it's near the end, guys. Yeah, so the diagram shows a square on a centimeter grid. Find the perimeter of the square. Give your answer in the form A root B. So to work out this length here, we go across 1, 2, 3, and up 3. So we've got 3, 3. So to work out the diagonal, I'll call that x. It'd be 3 squared plus 3 squared square rooted will equal to x. So x is equal to root 18. Okay, a square has all the same side lengths. Okay, so there, bang, 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 bang. So it'll be 4 lots of root 18. Root 18 can be simplified as a third. Okay, so 9 is the biggest square number factor that goes into it. So 4 lots of root 9 times root 2. Root 9 is equal to 3. 4 times 3 is going to be 12. So the answer will be 12 root 2 centimeters, and that's in its exact form. Okay, so A equals 12 and B equals root 2. Okay, hopefully that makes sense. Okay, the square ABCD has a perimeter of 1 meter. Calculate the length of diagonal AD. Okay, so it has a perimeter of 1 meter. So if I do 1 divided by 4, that will give me the side length here. So that'll be 1/4 there, 1/4 there, 1/4 there, and 1/4 there. So to work out the length AD, I'm going to use Pythagoras' theorem. Okay, got my right angle triangle here. It will be a quarter squared plus a quarter squared square rooted. Okay, so that'll be the square root of 1/16 plus 1/16, which would be the square root of 2/16, which would be root 2 over 4. Okay, or you can have it as the square root of 1/8. Okay, that would also suffice. Okay, so once it in this exact form, so we'll leave it as root that actually, or I'll write it as root 2 over 16. Okay, for that one. Okay, so that's my final answer. There we go. Okay, root 2 over 4. Oh. Okay, this next question, the diagram shows the line segment, okay, joining O to A. The gradient of OA is 2. The lengths of the side segment is 2, 4, 5. Okay, work out the coordinates of A. Okay, so if the gradient is 2, okay, so this will be like, let's say we'll call that x0. Okay, there. That'll be xy. So the gradient would be y minus 0 over x minus x. Okay. Okay. So let's label this. Okay. So it goes across 1 and then up 2 years. So gradient of 2. So it has to go across 1 and up 2, or across 2 up 4. Okay. So that's the idea here. So if I label this as x, this will be equal to 2x. Okay. And now I'll have x squared plus 2x all squared is equal to 245. That would be 4x squared plus x squared, so that would be 5x squared is equal to 245. Dividing by 5 on both sides, we get x squared is equal to 49. Okay, therefore x is equal to 7. So if x equals 7, okay, that'll be 7. That'll be 14. So the coordinates of A would be 7, 14. Okay, and that does confirm that my answer is correct. Okay, because the change in y divided by change in x, it'd be 14 minus 0 over 7 minus 0, which gives us 14 sevenths, which simplifies to the number 2. So that does confirm that my gradient here also equals 2 there. Okay, there we go. Quite a nasty question. The area of the rectangle WXYZ is 882 centimeters. The height of the rectangle is double the width. So we'll call the width, oh no, sorry, that's the height, sorry. The width will be x, the height will be equal to 2x, okay? So we'll have 2x times x is equal to 882. So we have 2x squared is equal to 882. Dividing both sides of the equation by 2, we get that x squared is equal to 441. X equals the square root of that, which gives us the number 21. Okay, so x is equal to 21 centimeters. So here that'll be 21. And here that'll be 42 centimeters. Okay, however, it says calculate the distance from w to y. So you using Pythagoras, is the square root of 21 squared plus 42 squared. Okay, if we bring that into a calculator, okay, we'll get the answer as approximately 47 centimeters to the nearest whole number, guys. Okay, there we go. Okay, last two questions to go now. So, a television screen has a diagonal length of 144 centimeters. So diagonal length, so that way like that, okay? The ratio of the length of the television to the width is 16 to 9. Okay, so calculate the width, of the television screen. Give your answer to one decimal place. So, the length, we'll call that 16x. The width, we'll call that 9x. Okay, so 16x all squared plus 9x all squared has to equal 144. Okay, that will give me 256x squared plus 81x squared is equal to 144. So that means that I've got a total of 7, 3, and 3. So 337 x squared is equal to 144. Rearrange this, so divide through by 337 on both sides, and then square root both sides. We get that x is the square root of 144 over 337. Okay, which if you bring into our calculator, okay, we'll get that x is equal to 7.84479 dot dot dot. It wants the width of it, so I've got to times that by 9. Okay, if you do that, okay, so let's have a look here. Sorry. Oh, I can't get a fraction button on this one. One second, guys, 1 second. Let's get my calculator up on my phone, sorry. So the square root of 144 divided by 337. Why am I getting a different answer now? What? Oh, sorry, that's equal to 144 squared, guys. I apologise. Sorry about that. 144 squared. Okay. So the square root of 20,000 divided by 337, so 7.84 times up by 9. Oops. Click the right arrow, times it by 9, and we get the answer of approximately 70.598, okay, centimeters to 3dp, guys, okay? Oh, sorry, it's saying 1dp, sorry. So the answer would be 71.0 centimeters to 1dp, guys. Okay, sorry about that. Okay. Oh, I think there was a mistake actually. So I got 70 point. Oh yeah, sorry, 70.6, guys. Yeah, not 71. Sorry, 70.6. Sorry, I apologize. I wrote it wrong actually. So sorry, it's 70.6. It should be, not 71.0. I apologize. I copied out wrong there. Okay, a television screen has a diagonal length of 50 inches. The ratio of the length of the television screen to the width of the television is 4:3. So calculate the area of the television screen. So we're going to have 4x all squared plus 3x all squared is equal to 50 squared. So that's going to be 16x squared plus 9x squared is equal to 50 squared, or 2,500. Okay, I'm going to get 25x squared there is equal to 2,500. Divide by 25, so we'll get x squared is equal to 100. X is equal to the square root of 100, so x is equal to 10. So x equals 10 inches, okay? So the length of the diagonal okay, so the area of the television screen is 4x and 3x, okay? So that'll be 40, that'll be 30. The area is length times width of a rectangle, okay? Or like a TV, you could say. So 40 times 30, which is 1,200, guys. So 1,200 inches squared. Okay? And there we go, guys. Okay? There we go. Okay? So there, guys, is my final answer. And that concludes today's long video, okay? Hopefully that was helpful, okay? Sorry if I rushed out any bits, and sorry if I made any mistakes. Please forgive me, okay? I am only human, okay? If you found this useful, please like, comment, share, subscribe, follow me on TikTok, guys, okay? And I've got another video like this here, hopefully coming out very soon, okay? Thanks so much for watching, okay? And check out my most recent video on this, on circles and areas and circumference of circles, okay, and also some videos here from last year where I looked at directed numbers, okay, and also area, okay, of 2D shapes, okay. Hope you found it useful, okay, and I'll see you in the next one, okay. Bye for now, take care, all the best, guys, keep well, keep safe.